In this section, I'm going to show you how to create an impedance diagram, and at the same time how to plot the impedance fault trajectories from a record captured by a Tesla 3000 fault recorder. At the same time, you can superimpose your distance relay zone settings into the same impedance diagram. One of the advantages of plotting my impedance fault trajectories along with my Mho circles is to determine whether or not the distance relay issue a trip on the proper zone. What you are seeing on your screen is the final result of the fault impedance trajectory plotted with your Mho circles of that distance relay. I'm going to show you how to create this final result on a step-by-step procedure. I'm going to go ahead and start by closing all these windows down. The first thing you're going to need is the fault record from that Tesla 3000 DFR. Once the Tesla 3000 DFR has captured a record, it would issue a file with an extension TLR. Or if you're using record-based view, you can start the record by just double-clicking on it. If you have a separate file like I have here, all you gotta do is do a right-click and start record-based view. I'll launch the graph. Double-click on my record, and all my oscillographic data is going to show up. Now, in order to plot my impedance diagram, I'm going to need to know which currents and voltages I want to plot. In this case, I'm going to go ahead and plot my voltages and my currents on this line right here. In order to plot my impedance diagram, I'm going to have to create a view, and this is done by clicking on this little icon on top of your screen. You can create a timeline overlays, symmetrical components, harmonics, and impedance view. So I'm going to choose my impedance view here, and this is my impedance view with no voltages and currents superimposed into the diagram. Therefore, choosing my voltages and choosing my currents would actually plot them on the diagram. Now, how do I import my relay settings? Well, if you are using an ERLPhase LPRO 2100, you can import a file by just clicking on this little target icon here and finding your setting file, such as this one. This is my LPRO setting file. Now, if you are using another relay, such as a Spicer relay, you can actually manually import your zone characteristics, your settings, into my LPRO. What you gotta do is you gotta go into protection functions, my face-to-face characteristics, and then manually input your zone reaches right here, 8, 9, 60, 12. That's 80% of my line, 120 and 150. Once you have imported or added the zone characteristics reaches into my LPRO software, you have to save that, and in this case I already saved it as my impedance reach settings, and that's what you're going to need in order to import into my impedance diagram over here. So I'm going to go ahead and import my impedance settings here, and I'm going to plot my face-to-face impedances. Therefore, I need to check every box over here. You can also plot your line impedance, your load impedance. You can also plot blinders or a directional element if you wish to. Then choose all your zones that you want to superimpose into this diagram and apply it. Once it is applied, the Mho circles will appear on your screen. Here's the final result with my fault impedance trajectories plus my distance relay Mho characteristics on the same diagram. Now we can appreciate that my zone impedance here and my line distance relay impedance has penetrated into your zone 1 settings. On the same way, zone 3 has also been penetrated by my B2C impedance. This is how you actually plot impedance characteristics or impedance fault trajectories with your Mho distance relay characteristics settings. I hope this is helpful for you. If you are actually using a fault record from a SEL relay or another type of relay, you have to import it as a comp tray file. And you can actually do that by importing that comp tray file. I click open and double click on my record. In this case, this is what I have. Now, on the same manner, I can go ahead and create my impedance view from this comp tray file record and plot my voltages and my currents that I want to investigate. And here it is. Now, you also have to import your distance relay settings, and on the same manner, you're going to have to use the ERLPro setting software in order to put your zone characteristics for that particular relay or that particular line. Once you have done that, you will have to save it and then import it using retrograph. So I'm going to import my ERLPro setting file with my SEL characteristics that have been inputted into my ERLPro software, and I'm going to open that. And on the same manner, I'm going to plot my face-to-face characteristics plus my zones, my Mho circles. You can also do quadrilateral characteristics when you are in the face-to-ground mode. You can plot that if you wish, but in this case we're doing a face-to-face, and you're going to apply that and you're going to close it. And as we can see here, the fault never got into the zone characteristics. Partly is because I don't have the relay settings for this particular record. This is just an example of how to plot the Schweitzer settings with the ERLPro software. Now, if I wanted to do the zone, face-to-ground impedances, I can also do that. I have to check this box and I apply it, and there it is, and then my impedance has changed a little bit. But again, since this is not the right settings for this particular fault file, I'm not going to get the right results. However, this is how you imported the comp tray file, and this is how you actually put your Schweitzer settings into the ERLPro characteristics in order to import into the impedance diagram or into retrograph. I hope this is helpful for you, and if you got any questions, visit our website and contact. If you got any more questions, contact our customer support, and we'll be able to help you out. Thanks.